My name is Kim Curris. I am a senior, and I'm majoring in music and psychology.
I'm Trevor Wallace. I'm a senior applied physics major.
And I'm Jacob Gerson, an electrical engineering major. I'm a junior.
So our project is called Synth-esthesia, and it's based on the multi-sensory experience of synesthesia. If you don't know, synesthesia is a phenomenon where multiple senses are like intertwined. So some people experience the coalition of sight and sound, for example. So this was our main inspiration for this instrument, and we wanted to create something that had a really strong visual aspect to it. And there were a lot of different ideas and iterations of how to do this, but we ended up using a computer to be our digital canvas. First of all, we have this like painter's box that was made by Julia. And on the box, we have a color palette with a circular soft pot here that is hooked up to an Arduino, and that is how you pick your color. And we have all 7 colors of the rainbow. And then your foot pedals down here allow you to draw. You have to hold it down and the drawing function is enabled, and then the left foot pedal is to change the brightness of the color hue. And then the main controller here has a reset function which turns off the sounds and clears your canvas and also recalibrates your position of where your paintbrush is. And then the bottom button here with the 4 LEDs picks which canvas / sound bank you're on. So we have 4 different canvases that you can pick from, and each of them have 7 different colors, and each of those 7 colors has their own specific sound. So in all, there's 28 different sounds to choose from, and they all evolve independently of each other. This first one is called Waterfall, and it's based off of Bob Ross' painting. Okay, this is called Cityscape.
The graffiti.
It's supposed to look like spray paint.
Yeah.
Like graffiti.
And the last one
I don't know
was,
if that is self-explanatory.
and the last one was nature.
They have car driving over there, yeah. The crosswalk is really loud. Crosswalk?
Oh, if you look at
It's getting annoyed.
and you can kind of hear that the pitch bend is mapped to the X position of the cursor. So when you're on that side, it'll be lower pitched than when you're on the right side. Which is kind of cool with some of the, like the crosswalk thing that's like a ticking noise, it speeds up depending on where you're positioned.
Okay, the next one is called Geometric.
The number of sides that the shape has and the size of the shape, it's kind of hard to see right now, are dictated by the color, and then the radius of the shape is dictated by how far out you're tilted. So you can kind of see that the shape like materializes from nothing. It's like really dark. Let me see if I can turn up the brightness and see.
Just turn
But if you're looking closely, the shapes aren't materialized. And the radius is defined by the yaw angle, and the pitch angle also dictates how the shape is rotated in space. It's like a chaotic system where like the attraction of the particles is defined by some like differential equation that somebody else figured out. And we took the code from a YouTube video. But, and when you tilt in the yaw angle, it changes how they're attracted to each other, and if you tilt it up and down, it changes how fast they're going.
But basically, we have this insane reason patch, as you can see, and there's 28 fully like separate modules, and then we have 4 buses for each 7 sets of sounds, which our max like note out logic corresponds to each of these 4 buses. For the more kind of spacey sounds, we used a lot of these grain sample manipulators because they really evolve over time, and that was a big theme, or like something I really wanted to emulate with the sounds was like something that would evolve in itself. We also use some Thor and Europa modules. Basically, we have the pitch wheel mapped to X and Y axis, which Trevor can talk more about in the max patch, but that's mapping to like, as you can see, like that pitch bend was all the way up, or this pitch bend is all the way down. And then we just kept it to a range of 2 octaves.
For our midterm, we used a Wii remote. And the way a Wii remote kind of maps to a screen, is it uses an IR camera. And there's a lot of weird optics and physics that goes along with that. So we ditched that and decided to make our own controller. So we manufactured this PCB, made it battery powered, and we were connected to this wireless CPU. It's kind of the ESP32 CPU that you see on the dev boards, and via I2C is connected to, if you can see this little black square up here, that's an IMU, and we're mainly just using the gyroscope on the IMU. The ESP32 is sending just packets asynchronously to a port that the max patch.
So like Jacob said, we're reading in all this data from the ESP32, and we're sending the paint state, which is which of the drawing patches we're on, the pitch angle, yaw angle, and then the slide pot, which is actually in this. So we're taking in the circular soft pot there, we're taking in now this potentiometer there, as well as the 2 pedal buttons, which we're calling C button and B button in reference to the B button on the Wii remote that we were using earlier. So this ranges from 0 to 1023, and we map that to 0 to 255 for like RGB hues, and then we map that to 0 to 2 pi, and this is like a trig function that basically takes you from 0 to 2 pi to 3 different RGB values that go across like the color wheel. Out of all of this math, we'll output 3 RGB values and a brightness, and that will get sent to the note out logic. Our note out logic subpatcher is receiving whether the button's been pressed, what the brightness is, what our X coordinate is, what our yaw angle is, and scaling that, as well as what our paint state is, which are the things we have. They kind of go in order of like complexity. This first one is just pulled from the Max Basic tutorial for like mouse drawing. This one is like the paintbrush thing, which was also kind of adapted from a Max tutorial called Scrolly Brush. So if I activate this when I'm drawing, it kind of moves with me. And then there's this one, which is the geometric. So if I put it on the smallest color, it will draw triangles. And as you hold the button down, it gets brighter. And if you move up and down, you can see that it rotates. And if you move outwards, it gets a bigger radius. The last one is this one. It's called Attractive here.
So cool.
It's like a dynamical systems like physics engine kind of, where all of these particles are attracted to one another via this differential equation, which is called the Tomas attractor. That's what this equation is. So it pretty much takes in this parameter B, which is like the attractiveness of the particles to each other, and dt, which is like how fast it's going, and that tells the particles how they're going to move. And then from there, I'm routing the mouse or the virtual mouse. If I'm on this side, it slows it down. If I go over here, it speeds it up, which is the dt parameter, and then this controls the shape of it with the b parameter as well.